Good morning. I'm Man Chow, Kenneth Chow. Today's topic is my quantum gravity video number 33. There are three topics today. One is an alternative way of computing the cosmic microwave background, CMB. The temperature is, of course, well known, 2.73 degrees Kelvin. And second topic is an alternative explanation for the missing electron neutrinos. The third topic today is a proposed solution for the cosmological constant problem. The first topic is I am beginning on the first topic, the alternative way of computing the cosmic microwave background. My theory, as well as I've been talking all my videos, is the Planck black hole comprising the de Broglie matter waves theory, together called the new hydrogen atom model. The theory is just simply this, that the Planck black holes are composed of de Broglie matter waves. From the outermost part, the outermost shell, the electron, the CR, the Compton radius of which, the Compton radius means the Compton wavelength divided by 2 pi. And soon after, they just call them CR for abbreviation. The electron, the CR of electron is 3.86 times 10 to the power minus 13 meter. And then the CR of the proton is 0.2103 times 10 to the power minus 15 meter. All the other known particles, they have individual specific CR Compton radius, as I said previously. And the ring singularity means the Planck black hole. The CR is of which is 1.616 times 10 to the power minus 35 meter. The neutron is a hydrogen atom, just simply the same as any other hydrogen atoms, but with the associated electron compressed by gravity to the proton, and until the CR becomes 0.21 times 10 to the power minus 15 meter. Just in other words, just 0.00003 meter less than that of the proton. The following diagram, which I'm going to show you, which is not drawn to scale, is a description of the dynamics of the de Broglie matter waves. This is a sideways diagram. It means it's from the side, looking from the side. This diagram shows what is a mathematical description of the de Broglie matter wave. The de Broglie matter wave is a wave function. The wave function which is sine theta divided by theta, and And what is zeta? Zeta is equal to bracket dEdP. That means the derivative of energy with respect to the log the density times t minus x. X is the position of the wave function, and multiplied by delta p, delta log. That means the rate of change of log divided by 2h bar. H bar is of course well known is the Planck's constant divided by 2 pi. At the center, this is the meaning of sine theta divided by theta is a mathematical function. At the center of the de Broglie matter wave, the singularity, which is the singularity of the Planck black hole, the de Broglie matter wave simply jumps across and changes from moving inwards to moving outwards at the vacuum light velocity c. That means at the center here, this wave coming from this side, it jumps across at the red light velocity, and this is 2 times 1.616 times 10 to the power minus 35 meter. This is the Planck's length radius. At red light velocity, and it is the time is taken to cross it just the order of Planck time. It's about 10 to the power minus 44 seconds. And what about the data of the wave, of this wave function at the wave center as a singularity? It is 1 energy, the Planck energy is square root h bar multiplied by c to the power 5 divided by g, the Newton's gravitational constant, all square root, all taken and all square root of this whole thing. And what about the mass? The mass is Planck mass, square root of under square root sign h bar multiplied by c, the light velocity, divided by g, Newton's constant, kilogram, equal to 2.177 times 10 to the power minus 8 kilogram. What about the radius? The radius is the Planck length, which is square root of the h bar multiplied by g, the Newton's constant, divided by c to the power 3 c cubed meter, equal to 1.616 times 10 to the power minus 35 meter. And what about the velocity? The velocity, both the phase and the group velocity. The phase velocity means the wave roughly meaning the velocity of spinning of the wave. And group velocity simply means the movement, the displacement of the wave, the linear displacement. All these are at the light speed of c, meaning 3 times 10 to the power 8 meter per second. And then it has a frequency. All wave function has frequency, all waves, and this is equal to 3 times 10 to the power 8 divided by 1.616 times 10 to the power minus 35 Hertz. Hertz means cycle per second, equal to 1.856 times 10 to the power 43 Hertz. This is by the Planck black hole equation number three, which is in my video 30. Equation number 3. The meaning is that means it is c divided by the wavelength. The quantum radius now called the wavelength. I call it for convenience sake. But you must remember the wavelength divided by 2 pi is the quantum radius. But the quantum radius now is the wavelength. And so it's equal to the frequency, the 1.856 times 10 to the power 43 Hertz. And what about the temperature? The temperature is a Planck energy divided by the Boltzmann constant, 1.381 times 10 to the power minus 23 is equal to 1.418 times 10 to the power 32 Kelvin degree. This is the Planck black hole equation number 5, equation 5. You can always get all this by my video 30. And so this. And now, the question is, what is the data of this wave at the quantum radius of 8.4 times 10 to the power minus 4 meter? As I show you here, the wave move here, jump across, and then it drop to a low amplitude, and then continue to move. What about when it comes to here? 8.4 times 10 to the power minus 4 meter. And the data here is one frequency is equal to 3 times 10 to the power 8, that's c, the light velocity, divided by 8.4 times 10 to the power minus 4 meter is equal to 3.571 times 10 to the power 11 Hertz. The energy becomes 1.055 times 10 to the power minus 34 joules second. This is the h bar, the Planck constant, divided by 2 pi. Multiplied by 3.571 times 10 to the power 11 Hertz. And the result is 3.767 times 10 to the power minus 23 joules. This is by the Planck black hole equation number 4. You can also get this from my video 30. And now what's the temperature of this of the wave when it is at CR 8.4 times 10 to the power minus 4 meter? The temperature is equal to the energy divided by 1.381 times 10 to the minus 23 joule per degree Kelvin, which is the Boltzmann constant, and the result is 2.728 K, that is approximately 2.73 degree Kelvin. Now this is the alternative way of computing the cosmic microwave background, which is topic number 1 of my topic today. This is a way of the alternative way to compute the CMB temperature of 2.73 degree Kelvin. Now, I'm going to show you another diagram. This I finished my topic number 1. My following diagram, which is also not drawn to scale, is a top-down diagram of the previous diagram. The previous diagram is this, of course, you've already seen it. And now the top, this is a sideway from looking from the side, the sideway diagram. This is the looking from the top downwards, top-down diagram. And I'm going to, with reference to this diagram, and I will quote from a book by the professor of astronomy of Harvard University, Mr. Abraham Lowe, which is How Did the First Stars and Galaxies Form? A book on astronomy. I'm going to read it first, to quote it from the briefly, very briefly. Two important transitions of the hydrogen atom between two slightly separated hyperfine states of the ground energy level, n is equal to 1. In the higher energy state, the spin of the electron, E, is aligned with that of the proton, P. And in the lower energy stage, the two are anti-aligned. A spin flip of the electron results in the emission of a photon with a wavelength of 221 centimeters, or a frequency of 1420 megahertz. I first refer to the diagram. This is the hyperfine level of the hydrogen, is meaning this here. The top level. Here is the coded message. The passage means the message of the coded passage means that by the spin of the electron E, the spin of the electron E is either aligned or is anti-aligned with the proton spin. Here, so in pink color, all these pink colors are related, and pink color related. when the electron, the spin of the electron here in this level is aligned, that means aligned means in the same direction with the spin of the proton, and it's in the higher energy state. When it's anti-aligned, it means it's in opposite direction, aligned, one facing this way, the other facing the opposite direction, then it is a lower energy state. And this, the flipping of the electron causes a photon, which is a microwave photon, to be emitted from this at this level, at the topmost level. That's the meaning of the passage. And this photon the wavelength is 21 centimeter. That's why it's called the 21 centimeter hydrogen. And its frequency is 1420 megahertz. Actually, you can wavelength, frequency, energy, velocity, etc. are all related, can all be calculated easily, very straightforwardly from this equation, equation 3, Planck-black hole equation 3, Planck-black hole equation 5, and black hole equation 4. All these can be easily and straightforwardly calculated. So there's no difficulty about this frequency, wavelength, etc. Now the second transition is between the level n, the energy level n equal to 2 and the energy equal to 1 levels. This results in the emission of a Lyman alpha photon of wavelength equal to 1.216 times 10 to the power minus 5 centimeter, or the frequency of 2.468 times 10 to the power 15 hertz. This is quoted from the page 137 of the book, How Did the First Stars and Galaxies Form? The meaning is that the second transition is between this N1. I intentionally paint this color paint. N is equal to 1 and N is equal to 2. This between this, the flip of energy between this, the switch of energy between these two levels. And this causes a photon, also a Lyman alpha photon of wavelength 1.216 times 10 to the power minus 5 centimeters. To be emitted when a transition between these two levels occurs, then there is an emission of a 1.216 times 10 to the power minus 5 wavelength photon. This photon is, I calculated it already, it's a UV radiation. It's a UV photon. That means it's an ultraviolet photon. Now, I quote the second passage from the book. Hydrogen tend to thermalize with the CMB, making the IgM unobservable. If other processes shift the hyperfine levels populations away from the thermal equilibriums, then the gas becomes observable against the CMB, either in emission or in absorption. The relative occupancy of the spin level is described in terms of the hydrogen spin temperature Ts. S means the spin. Its meaning is that now I refer to this second level is called the CMB. The first level is the 21 centimeter hydrogen. The second level is the CMB, which is of 8.4 times 10 to the power minus 4 meter. CR means a quantum radius, as I said already. And this is the cosmic wave background, CMB. And this is a microwave, as its name implies, it's microwave. The meaning is that this is the first level is you have the CMB, you have the IGM. This is called IGM, intergalactic medium. That means actually the hydrogen gas. But this is not actually the gas form is in UV radiation form. That means this UV radiation will be unobservable against this cosmic wave microwave background CMB because it tends to thermalize with the CMB. The same thermalize means of the same temperature. When it's of the same temperature, when it's detected from a far distance, you can just detect the CMB, but not the gas, not the hydrogen gas, the intergalactic medium. But if other processes shift the hyperfine levels from thermal equilibrium, if just as I mentioned, there's an emission of the 1.216 times 10 to the power minus 5 centimeter photon, and also the emission of a 21 centimeter photon hydrogen. In such cases, the levels are shifted away from thermal equilibrium. That means they're no longer of the same temperature. Then they become observable in these cases. But it said the IGM, the intergalactic medium, the hydrogen gas, is observable only when the kinetic temperature, Tk, of the gas differs from the cosmic microwave background temperature, that means 2.73 degree. And an effective mechanism couples the spin temperature to the kinetic temperature. That means that it's very rarely, in rare cases and occasionally, such cases occur that thermal equilibrium will be breached. I mean, only in such rare circumstances, the hydrogen gas can be observed against the background of the CMB. From all these, the coded passage, the meaning of the coded passage, and the diagram, you can observe the CMB is here, 21 centimeter hydrogen here, and the galactic intergalactic medium is here, and the 21 centimeter hydrogen N is equal to 2 is here. That means it's clear from this diagram and from all the coded passage, the meaning of coded passage, that the CMB is actually a part of the 21 centimeter hydrogen system, and it surrounds all around the CMB. But the CMB is the most easily detectable part of the system. The hydrogen gas of the rest of the system can only be observable in rare cases and occasionally. The second conclusion you can draw from this is that the fact that the CMB is observed to fill the celestial sky, the global sky, therefore implies that the element hydrogen, element number 1, is ubiquitous in the universe. That means if the CMB is part of the hydrogen system, and if the CMB is observed to fill the whole celestial sky, then it simply means the hydrogen is ubiquitous in the universe. And this fact also at the same time explain why the h bar, that means the hu divided by 2 pi, the Planck's constant divided by 2 pi, and the elementary charge E and the elementary charge E square are universal. This also explains the second fact. Because the hydrogen is everywhere, you cannot escape it, you cannot avoid it. It's everywhere, so h bar and e and e square are also universal everywhere. And the third conclusion can draw is that since the hydrogen atom, in this case we are talking about a hydrogen atom, but the Planck black hole is also from the Planck black hole we have developed this from the Planck black hole theory, right? From the beginning, I'm talking about the Planck black hole, and then let's become the hydrogen system. That means the hydrogen atoms and the Planck black holes share the same data and same equation, all the same, the Planck black hole equation, but it applied to the hydrogen system. That is a conclusive evidence that the Planck black holes and the hydrogen atoms together are parts of the same physical entity. Let's just finish up my first part of my today's topic. The second part is very short. Is an alternative explanation for the missing electron neutrinos. From the diagram, also referring to the diagram, here I especially drawn out in pink, in indigo color. Here you have a quantum radius 0.988 times 10 to the power 7. The temperature is 11608 degree Kelvin. It is an electron neutrino. And here you have, on this level, we have two ultraviolet photons, each of quantum radius 1.976 times 10 to the power minus 7 meter. Temperature equal to 11,608 degree Kelvin. That's the same temperature as this one, as the neutrinos. And these two ultraviolet radiation photons. You can see from this diagram that on the outward journey, this is from the center on the outward center journey, from the singularity, the electron neutrino splits into two ultraviolet photons, each of quantum radius 1.976 times 10 to the power minus 7 meter. That is ultraviolet radiation. This naturally explains the disappearance. That is, they become UV radiation. They disperse and they rareify, and then they become undetectable. This is a natural explanation. You can contrast this with the conventional explanation for the missing neutrinos. This is a natural explanation from this diagram. All this can be drawn to this diagram. Outwardly, and then become two photons, UV photons, and then they disperse. It's a radiation already, so it becomes rarefied and undetectable. I'll come to finish the second topic today, and I'm going to the third topic. I suggest a solution of the cosmological constant problem. What I mean by the cosmological constant problem? It refers to a huge discrepancy between the observed mass density of the universe. This observed mass density is between 1 to 2. 1 to 2, between 1 and 2. 1 times 10 to the power minus 26, 10 to the power minus 26 kilogram, to 2 times 10 to the power minus 26 kilogram. This is not a definite estimate, but within a range of 1 to 2 times 10 to the power minus 26 kilogram. And there's a discrepancy of 10 to the power minus 122, 10 to the power minus 122. This factor is a huge factor of discrepancy between the mass density computed by the physicists using what they call effective field theory and a dimensional analysis method, and the actually observed mass density, you say between 1 to 2, 10 by minus times 10 to the power minus 26 kilogram per cubic meter. Density unit is kilogram per cubic meter. Now I propose a solution of this cosmological constant problem. In both videos 16 and video 28 of this series, I base the current mass density of the universe on the amount of radiation emitted from the stars, from all the stars, all the galaxies, all the quasars, all the Safed galaxies, all the supernovas, etc., etc. Everything which emits radiation in the universe. And in video 28, I actually make a rough estimation per year. This estimation per year of 1 trillion solar masses. How did I make this estimation? I make this estimation based on the number of galaxies and stars as surveyed in survey result 2012 of the NASA's. That means the aviation. The NASA is well known. You know what that means. The NASA's Wilkinson microwave and isotropy probe, abbreviated WMAP, satellite data. That survey said that there's about 1 trillion galaxies, which comprising hundreds of sextillions of stars. Sextillions of stars means 10 to the power 21 is sextillion. Based on this estimation, then I make my rough estimation that is per year there is a total amount of emission of radiation of about 1 trillion solar masses into the universe from all the stars, all the galaxies, all the quasars, all the Safed galaxies, all the supernova, etc. But however, I now came across some news that in a recent survey, these numbers of galaxies and stars have become double of that of the 2012 survey result. This means that my rough estimation has to be revised from 1 trillion solar masses to 2 trillion solar masses per year. That is, the mass density will then be calculated like as this. Two here means 2 trillion masses, 10 to the power 12, and times. This is the solar mass, 1.989 times 10 to the power 30 kilogram. That's the mass of the sun. And what is this 10 to the power 10? It's the estimated. This is the rough estimate of the number of years the emission has taken place, and divided by the volume of the universe. There's this equation of the volume of the universe 2 times pi 2 times 10 to the power 26 to the power 3. This is the radius. This denominator of the volume of the universe is equal to 2 pi radius to the power 3 is Einstein's formula for volume of the universe in page 91 of the selection from the Principle of Relativity, 2002, of which the 10 to the power 26 is the radius of the universe in meters. And then you got the result, final result from it is 0.20153 times 10 to the power minus 26 kilogram per cubic meter. I've got the result. This is a much nearer match to this to the astronomer's observation of 1 to 2 times 10 to the power minus 26 kilogram per meter per cubic meter. This is much nearer, of course, although it's not the same, of course. And this much nearer match is reconcilable with the observational value of the astronomers, which is 1 to 2 terabytes times 10 to the power minus 26 kilogram. This is it can be reconciled. It's easily reconciled with it because the 10 to the power 10 years of mission is simply a rough estimation, and the other values are roughly estimated, so it can be reconciled with the also rough estimated 1 to 2 times 10 to the power minus 26 observational value. This can be easily reconciled. This is my suggestion for solution of the cosmological constant problem. I better finish here. So if you're interested, subscribe and like and subscribe. I stop here. Okay.